Good evening, all. Uh, so this is Srivatsa. I think some of you may have met me, some of you haven't yet, and we will get started within a minute so that we can hope more kids will join, more of your friends will join. Okay. Okay, let's get started. And let me share the screen. Okay. All right. So let's get started with our mathematics sessions of AWS, as we called it. So this is the quick thing. Okay, let me pull this guy down. Right. So there will be a set of problems that we will go through, and as and when required, in terms of the let's say concepts that needs to be highlighted, and maybe some of you who have not yet studied certain of the concepts, we will quickly mention that. You can make note of that, and then we can offline, you can spend the weekend and after to discuss the problems, okay, and learn those new concepts that you may have. So here is our first problem for the day, and let's get started with this. Okay, so the format in which I would like to take it up is I'll give you possibly a minute to read the question and make sense of it. And I'm sure you all have your pen and paper book so that you can quickly start working. A minute and a half or so, if you can give me the answer, that's good. Else, in the next 1 or 2 minutes, we will have our answer discussed. Okay. So go ahead, start reading the problem and look at the first problem. Okay. Okay, so let's see if anyone has got the answer. Any approach suggested how to go about this problem? You can unmute and speak. No one? Okay. So if x is equal to a, y equal to b, z equal to c is a solution of the system of linear equations. So there are 3 linear equations. And one quick observation, notice that all these equations are equated to 0. So that means these are called the homogeneous equations. Okay. And if this solution x equal to a, y equal to b, z equal to z, c should be a solution of this and also lies on this plane, then what is the value of this? So how do we go about it? So first thing we would look at is, for the homogeneous equations to have a solution, we must have the determinant of the coefficients formed by these equations should go to 0. So that's our starting point. So let's look at that. So the first equation gives me 1, 8, 7. Second equation will give me 9, 2, and 3. And the third will give me 1, 1, 1. Okay. And you know that x equal to a, y equal to b, z equal to c is a solution, right? That's also another thing important to know. So this determinant should go to 0. And this point ABC should lie on the plane x plus 2y plus z equal to 6. Okay. So you can quickly verify, is this determinant going to 0? That's the first step that is required for you, right? So what do you think? Any ideas after writing that? Did you verify if the determinant went to 0? Okay. So you can check that, right? The determinant of this set should go to 0. That's one of the first conditions to verify. If it is not, then something is wrong, right? So 2 minus 3 minus 1, 8, 9 minus 3, 6. Or you can pick the last row to expand. Okay. I'll leave that for you to verify. So now the next step that we are looking at, this is where the kind of trick works out, which is that let us say if x equal to a, y equal to b, and z equal to c. So now if you notice, there is the x and x, the first and the third equation have x and x, right? So let me subtract the two. So which means x plus 8y plus 7z equal to 0, x plus y plus z equal to 0. So if I subtract these two equations, what is the logic? Logic is to eliminate one of the variables. So when you do that, you get 7y plus 7 minus 1 is 6, z equal to 0. So that means you can write one in terms of the other. Similarly, if you observe any other equation, 2y, 3z, so you can multiply and eliminate another variable, so that, or you can keep it as is, and see that if I were to put in some value, for example, x is equal to some alpha. Now, the idea is if x is equal to alpha, someone has to mute. Okay, so x is equal to alpha and 7y equal to 6z, right? So is there a way to write everything in terms of x? So that's what we should look for. And so we have eliminated, okay, we have eliminated x. So that means I must look at similarly x plus 8y plus 7z equal to 0, and 9x plus 2y plus 3z. Okay, so the z and 2 looks the same, so be careful with that. So now if I were to eliminate y from this, so, and I can subtract, so multiply by 4 and then subtract. Okay, so that is 36 minus 1, 35x, 8 minus 8, 0. So 12 minus 7, 5z equal to 0. So I can write this, say 35x, x is equal to minus 5z by 35. Okay, and here I can write 7y equal to minus 6z, or if I were to rewrite it as this, z equal to minus 7x. Okay, so the same way if I write it here, so y is equal to minus 6 into minus 7x by 7. So that becomes plus 6x. So if you notice, I have written the y and z in terms of x because we don't know the values, right? So that is where we are able to write x and y and z in terms of x. Now, if x is equal to alpha, let's say if this point, the solution has to be on this plane, x plus 2y plus z equal to 6, then that means I can write in terms of alpha, and 2y becomes 2 into 6, x is alpha, right? So 6 alpha. So that means 2 into 6 alpha plus z is minus 7x or minus 7 alpha. So which is minus 7 alpha equal to 6. So from this, we got an equation only in one variable, which is alpha. So let's find what is alpha from this equation. So 12, 13, 13 minus 7, 6. So therefore 6 alpha equal to 6, or alpha equal to 1. Now that we got the variable alpha equal to 1, I can look at what is x, y, and z. So this implies x equal to 1, y is equal to 6, and z is equal to minus 7, because x is equal to alpha, right? Which was equal to a, b, and equal to c. So what is the final requirement? We want to calculate 2a plus b plus c. So therefore 2 into 1 plus b is 6, then plus c, which is equal to minus 7. So 6 plus 2, 8, 8 minus 7 is equal to 1. So 2a plus b plus c is equal to 2 into 1, which is a is 1, b is 6, I have substituted, c is equal to minus 7. So 2 plus 6, 8 minus 7 is 1. So the option should be, the answer is 1. So the option is the first one, right? I'm not able to pick on it for some reason. Maybe I'm not able to see it. Okay, so that's option. Maybe I'll write here option 1. Okay, so carefully observe. This verification part is left to you. You can do this part. Okay, what I have done is assume x equal to alpha. Okay, and then I try to eliminate x in 1 so that y is written in, or you can eliminate one of the variable, which I have done here and resubstituted. So you could have done it in another way where you keep x, eliminate y, in another eliminate z, so that you can write y in terms of x and z in terms of x. Then you get this criteria here, the constraint. So substitute in that to get the assumed value of x, which is alpha, the value for alpha, and then you substitute back and you've got the answer. Okay, so that's the approach for this problem. So there's this one more equation where there is 2 different types of concepts applied here. So there is the geometric progression, sequences and series, and the determinant part. So both these need to be looked into here. So first of all, one of the important things to realize is if you look at as LMN, here, if you are not able to see this, I'm assuming, see, this is log L, M, and N. Okay, so those are the terms of the geometric progression, and which are in the P, Q, and the rth term. Okay, so the PQR is here 1, 1, 1. So what is the approach for this? So one of the key important things to remember is what is a geometric progression? First term is A, next term should be AR, next is AR square. So something like L, M, and N, PQ, and R the term. So this is first, second, and third term. So I haven't written explicitly for that. I'll tell you why I have not written that. Now, what you can do is take log on of the sequence. Can you quickly tell me what will happen to the sequence of geometric progression? So this becomes log A, right? Then log of AR, so which becomes log A plus log R. That's our second term. And the next term will be log of A into R square, which will be log A plus 2 log R. This is the basic rules of logarithms that we have already employed and we have understood, right? So now if you look at this sequence, can you see that this logarithmic sequence is in, if this is in GP, this is in AP, right? So log of the geometric sequence will be always an arithmetic sequence. Why? Because there is a constant difference. What is the constant difference here? D. It should be log of R. Because when you subtract second term from the first, you get log A cancelled out and you get log R. And then third and second, if you subtract, log A gets cancelled out. 2 log R minus log R is 1 log R. So therefore, there is a common difference. So keeping this in mind, let's approach the determinant. So let's look at the log of L. So let us say if log L, which is the pth term. So what will be the expression? Now you can see it should be log A plus AR to the power of P minus 1 for the pth term. So therefore it should be P minus 1 into log R, where A and R are the first terms. Similarly, log M will be log A plus, it's the qth term, so therefore it will become Q minus 1 into log R. Similarly, log A plus R minus 1 into log R. Okay. Okay, there is an R here already. I should have changed it to something else. So maybe let me call this common ratio as some other variable. LM and PQR are done. So let me call it as X. Okay. X is the common ratio. A is the first term in that. Then the next column, which is PQ and R. And then last 1, 1, 1. Now, once we have written this, then we can see that this itself can be written in terms of, there is a log A, log A, log A, because there is a plus sign, right? So in one of the properties of the determinants is that if you can write this as the sum of two terms, any single column or a single row, then you can write this as log A PQR and 1, 1, 1 plus the other term, which is P minus 1, Q minus 1, R minus 1 into log X, which is common factor among all of them. So I can pull that out, log X. So P, Q, R, 1, 1, 1. Okay. So here again in the first determinant, log A is a common factor. So I can write this as log A times 1, 1, 1 PQR 1, 1, 1 plus here it's log X. Again, one way is to look at P minus 1, separate it again as PQR and then minus of 1, 1, 1. You could do that, or by doing the what is called as the row and column transformations, you could write this P minus 1, Q minus 1, R minus 1 as is. Take the second column, subtract the third column. So that means I'm going to do for this particular determinant from here to here, C2 is equal to C2 minus C3. Okay, I'm hoping that it is visible. Is it visible? Or maybe I'll use some other. C2 is replaced as C2 minus C3. So that means P minus 1, BQ minus 1, R minus 1, 1, 1, 1. So now what is it that we know about the determinants? If any two columns are equal or any two rows are equal, then the determinant is 0. So therefore this will be log a times 0 is 0 plus log x into, again this determinant is 0 because two columns are equal. So 0 plus 0 is 0. So the option is the last one, option 4. Okay, so I have employed all the properties of the determinants. One. Second, I've also observed that the logarithm of a geometric progression is a corresponding arithmetic progression, right? So that is one part. But other than that, very simple application is that when you take this, it is going to be simplified as log a. When you take the log of the L, it can be written in this form and this can be simplified. So this is extra information, as if you can say additional information, what happens to a GP when you take logarithm of the GP. Okay, so moving on to the next problem. The sequence of matrices is defined as given below. So there is a particular way of writing the sequence. So the first matrix is a 1 by 1 matrix, which has only one element, that is 1. The next element, the next matrix, the second matrix is having the next set of natural numbers, which is 2, 3, 4, 5. And M of 3, the third matrix. So as you notice, the first matrix, M of 1 is 1 by 1, has one element. Okay. M of 2 is 2 by 2, which has 4 elements. M of 3 is a 3 by 3 matrix, which will have 9 elements. Okay. Now, what is the and so on, then the trace of M17 is. So there are two parts to this. One is to find the matrix, other is to calculate the trace of the matrix. So we'll come to the trace second. First, let us see about what is the matrix. M of 17.
Sir, does trace mean the determinant, sir? Finding trace means it's determinant, sir.
Oh, no. I will come to that. Trace is actually a different quantity defined on a matrix. Like the way you can define a determinant, you can also define trace, which is different from determinant. So we'll come to that. First, quick thing we will look at is, so like the way 1, 2, 3 is there. What is the first element of this? One element only, so that is 1. What is the first element in this? 2. What is the first element here? Where does it start? It starts from 6, right? So in this way, what is that? Also look, remember M of 17. So let's get something clear. So if 1 is 1 by 1, second matrix is 2 by 2, 17, M of 17 should have a 17 by 17 matrix, which will have 289 elements. What is the first element? Because if I get the first element, then the rest of the numbers will be the corresponding number of elements. Like in the case of 9 elements of 3 by 3, the first element is 6. So from here, starting from 6, I can write the 9 elements. So the last element will be 5 plus 9, 14. So that is the 14 which is here, right? So similarly, if I know the first element, then I can write the next 289 elements and the corresponding diagonal elements. I'll tell you why the corresponding diagonal element also in a while. Okay, so can we first get what is the first element? Can you see a pattern here? For the first element, it is 1, then 2, and then 6. What would be the next element? And therefore, the 17th matrix first element.
Sir, will it be factorial of 17?
Factorial of 17. Okay, that's a very interesting observation, but it will not work it works for all the three. Oh my goodness, that's a very interesting situation. So let's see, can you get this one? What is the first element of this? M of 4, it should start with after 14, right? It should be
24.
15, the first element in the 4 by 4. 3 by 3 is 14, last element is 14 here. So M of 4 will start with 15. So now that you have 1, 2, 6, 15, the factorial fails. Correct? It should have been 24 according to one of you. But now that we don't have 24, but it starts with 15.
So could it be 1 plus 16 square?
1 plus? Okay, that means you are saying it is 1 plus 4 square is 17, but I got 15. So you're saying 4 square minus 1. So one way to check this part of this is, so let's find out the difference sequence. Okay, so I have 1, 2, 6, 15, and 2 minus 1 is 1. 6 minus 2 is 4. This is 9. So you actually getting the difference as the squares of numbers, right? That is obvious, right? Because there are n square elements in each of the matrix because it's a square matrix. So what should this be? So it means that you can look at it this way. 1 plus 1 is equal to 2, right? So 2 plus 4 is 6. 6 plus 9 is 15. So like this, if it goes on, what should be our, and then you can further look at it. Can we say up to here, how many elements are done? So it is basically 1 plus 4 plus 9 is completed, right? So up to here, for the 15, the one, what is the last element? To get the first element, I can directly try to get this, or find the last element of the previous matrix. Correct? Which is 24. 14 plus 16, sorry. One second. Somebody is, 31. Okay. So the last element is 31, it says here. Correct. Oh, is it 15? If it starts with 15, I have to write 16 elements, right? 14 plus 16 is not 31. Actually, it should be 30. Okay. So how did I get this last element? So let's see what are the last elements of the, okay, instead of this, let's look at last elements of each of them. So this is 1. Last element of this is 5, which is 1 plus 4. This last element is 14, which is 5 plus 9, right? So that means I must be adding the squares of the numbers, right? 1 plus 4, 5, 5 plus 9, 14. So that means for the M16, last element of M of 16 should be equal to 1 plus 4 plus 9 up to the 16 square, right? So this is nothing but sum of the squares of the natural numbers up to 16 with 16 terms, right? So what is the formula for sigma n square? N into n plus 1 into 2n plus 1 by 6. So I get, which is going to be 16 into 17 into 32, 16 times 2, 32 plus 1, 33 by 6. So now we can simplify this. There will be 3 11 times and 2 8 times. So 17 times 88. Can anyone quickly tell me what is 17 times 88?
96.
1496. Right. Okay. So what is the first term of this element then? 1497. Okay. Now, if this is the 1497, now what is the matrix I will get? So M17, if I have to write, the first number we have got is 1497. Now, how many numbers should I write here? Well, the next number will be 1498 and it goes on up to 17, right? It is a 17 by 17 matrix. So 1497 up to add 16 to this. 97 plus 6, 1503, 1513. Then you get 1514, 1515. So that's the number here. It's the diagonal. So this is how it goes on. Actually, we don't need to write down all the matrix elements. That's the interesting part of it. Why is what I will tell you here. So let me define what is called as the trace of a matrix, because that's the next part in the problem, right? So suppose if I have a matrix 1, 2, 3, 0, the trace of this matrix A, which I can write it as TR of A, is equal to 1 plus 0. So what is 1? It is the diagonal element, first row, first element, first column, and 0 is the second row, second column element. So sum of the diagonal elements, and remember it is the principal diagonal. So this is defined as the trace of a matrix. So if I have a 3 by 3 matrix, trace of A will be A11 plus A22 plus A33 for a 3 by 3 matrix. So for a 17 by 17 matrix, it will have A11, A22, A33 up to A17. Correct? A22 all the way till A17, 17. Okay. So now that I only need to know these diagonal elements, let us see if there is a pattern for the diagonal elements. Okay. So for that, let's look at this one. 2, 5, we won't be able to look for a pattern. But here, look at this M of 3. 6, 10, and 14. So what is the sequence of these numbers in the diagonal? 6 plus 4, 10, 10 plus 4, 14. So which means that there is a common difference between the diagonal elements. Okay. So here it was 4. So for M of 3, I got the common difference as 4. So for M of 17, what is the common difference I should expect from
18.
here to here? It should be 18. So verify that if it is correct. So 1497 plus 18. Is it 1515? Exactly, right? So that means I have 17 terms which are in an AP. Correct? Wherein, so the diagonal elements are starting with 1497, which is equal to A, with common difference 1515, the second term being D is 18. So how many terms are there in this sequence? 17, right? 17 terms are there. So now write down S n equal to 17 by 2 into 2 times 1497 plus 17 minus 1 is 16 into common difference is 18. Remember, I'm using the formula n by 2 into 2a plus n minus 1 into d. Okay. So now that we have got this, we can simplify this and finally have got the answer for it. So can anyone quickly, you can take out common factor 2 so that one thing will go away. So you get 1497 plus 18 into 8, which is 144. So now you can simplify this. 1497 plus 144 into 17. So this, anyone got the same value?
Yes, sir.
Okay, very good. So now let's check for the options. Is there anything which is matching your answer to the options provided?
Option 3.
Option 3. Perfect. So option 3. So if you notice, this whole thing is option 3 is, yeah, that's one, 27,897. Right? So what are the ideas that we have used here? Nothing but our basic common sense and kind of what we call as aptitude or the test of aptitude, right? So here we are just looking at the pattern and recognizing the pattern. Maybe some of you who have done NTSC and have done the mental abilities. This is a kind of problem with mental abilities. One such problem can be this, to find the first element, the next element and all that. So that's all. Only thing where we have used our next level of mathematics is here, wherein we have used the sigma n square formula. Right? After which we have found another pattern here, which is the arithmetic progression, for which we had to use the here the formula for Sn equal to, that's arithmetic progression. Apart from this, it is all common sense, right? And okay, one more thing is the definition relating to matrix. If we have done nothing in this, if you say, there's only one part of it, which is knowing the definition of trace. So trace is the sum of the diagonal elements. So let me write it in bold definition. Trace of a matrix is the sum of the elements along the principal diagonal. Principal diagonal. Okay, so that is the definition of trace. Notice that there is nothing related to the determinant here. So trace is another quantity, and later on you will study in linear algebra and the next level of this matrices and determinants. It turns out that trace and determinant are having unique properties, and that is why it has been introduced here, because irrespective of, oops, am I still connected with you guys? Can you hear me? Okay, so something happened and I was signed out for whatever reasons. Anyway, so we have this trace of a matrix, and that is what we have obtained the definition of the properties of this. Okay, so we've got the answer. The next problem, again, a system of equations has a non-trivial solution, then k is equal to. So again, observe, this is a set of homogeneous equation. So given set of equations are homogeneous equations. So which means that the determinant should vanish. So let's write down the matrix of the coefficients. So 3 minus 2, 1. then k minus 14, 15, and 1, 2, 3. And we know that this is the criteria for a non-trivial solution for homogeneous equation. Okay, should be equal to 0 for non-trivial solution to exist. Okay, so now quickly we can calculate the determinant equal to 0, so we get the value of k here. So that's as simple and straightforward as it can be. Okay, so the only important requirement is to know for the non-trivial solution, the determinant should go to 0. This is our key idea to apply. Once you do that, then the rest of it is simple. The one quick way of doing it is to, let's say, to calculate this determinant, you can expand it or do row and column operations to simplify it, calculate the determinant and find the value of k. So this is a pure number crunching. So I want you to note down this problem, or I will share this particular problem sheets, whatever I have created here in the group, so that you get an access to this entire document. And whatever we leave out like this as assignment, you can complete that in the process. Okay, so we will get chance to do and discuss more problems that way. Okay, so is that agreeable? Because there's no new idea here to discuss, that's why. Okay, next question. If the system of linear equations wherein the coefficients again are given and it's also set of homogeneous equation has a non-trivial solution, then the values of theta are. Okay, so here there is two parts to the problem, which is exactly similar to the previous problem, right? So therefore, again, for homogeneity, the non-trivial solution means the determinant should vanish. So which means I should get sine 3 theta minus 1 plus 1, and then cos 2 theta 4 and 3, 2, 7 and 7. And this determinant should vanish. Now, once you expand this determinant after simplification of sine 3 theta and cos 2 theta in terms of, you have first step is the algebra part, wherein the determinant should go to 0 for non-trivial solution. So that is concept 1, right? What is the concept 2 you will apply? Solutions of trigonometric equations. Because when you write down this determinant, you will have, okay, concept 3 is this, concept 2 is the multiple angles in trigonometry. Correct? So how to express sine 3 theta in terms of sine theta and cosine theta, or all in sine. Similarly, cos 2 theta in terms of, you can keep everything in sine, because sine 3 theta can be written in terms of sine alone. So therefore, you can also write this as, so anyone remembers what is sine 3 theta?
Three sine theta minus 4 sine cube theta.
Okay, and cos 2 theta?
One minus 2 sine square theta.
Right. Remember, we said that it should be written all in terms of sine theta. So now put this into that determinant wherever after expansion, and you get a equation in trigonometric ratio sine theta, some polynomial equation maybe, right? Now, after simplification, you get some equation, and you should solve that trigonometric equation. So solutions of the trigonometric equation, we know. If you get finally is sine theta equal to some value, Let's say sine theta is half. I'm not telling you exactly what it will come, but let us say sine theta equal to half, for example. Okay, not in this problem, any other problem. Just randomly, just to give you the flair for the solution, right? So sine theta equal to half, theta is how much? 30 degrees, right? Which is pi by 6. So, but you know that not only pi by 6, there are other angles also which are going to give you sine theta equal to half, which is the first quadrant. Then you also have one more angle, which is pi minus pi by 6, which is 5 pi by 6 is also. So if this is pi by 6 here, right? So that's the angle pi by 6. This will be 5 pi by 6. This represents the point for the angle 5 pi by 6. So there are two angles in 0 to 2 pi where sine is positive. But then we're not limited to this. We can keep going around any number of times, n number of times. So therefore, you get the general solutions of the trigonometric equation. So write down the general solutions of the trigonometric equation for the one which you get from this, and you can solve it. Okay, so final answer can be obtained from that. Okay, so these are the concepts that are required to solve the problem. So it's very straightforward. From there on, it is very, it's no longer any non-trivial, it's everything trivial after that. If you do these 3 steps, you should end up with an answer, and accurately one of the options here. Okay, so I'm skipping that also because we have discussed what is the need, and you can fill in the blanks of the calculations. Then this is another interesting problem. What does it say? It says matrix A is given by some number 6, 11, 2, 4. Then the determinant of a to the power of 2015. So that means they're actually calculating minus 6 times a to the power of 2014. Okay. So first of all, whenever there is this high powers of this, there should be some trick which we may want to calculate, need to do. So which is like, what is going to be for a square? So let's look at a square first and see whether we can see some kind of a pattern. Okay. And another thing also remember, before taking the determinant, maybe if you keep it as a matrix, because it's the same matrix multiplied again and again, I can write this as a to the power of 2014 as a common factor. So that means a minus 6i. Okay. And the determinant of this is like, there are 2 matrices. So this is like matrix A, or let's say matrix M, and this is another matrix N. So determinant of M into N is equal to determinant of M into determinant of N. Okay, so remember this. So now let's look at a square. What will happen to a square if I have the 6, 11, 2, 4? Because you will see that a to the power of 2014 has come, and then a minus 6i, we will see what happens. So what is a square? So that means a square is a square into a, sorry. So what will this look like? 36 plus 22. So that's 48. Then 66 plus 44. That is 110. 12 plus 8, 20. Then 22 plus 8, 30. Okay. So a square is a matrix which is like this. Okay. Why did we look at this? Oh, not necessary. Okay. I should have actually done this. This a minus 6i. So let's look at a minus 6i. So how will this be? So this is 6 minus 6, then 11 minus 0, and 2 minus 0, and 4 minus 6. Okay, so that's a minus 6i for us. So remember, 6 times I is the diagonal elements are I is an identity matrix. So therefore only the diagonal elements will have 6. So that is being subtracted here, minus 6, minus 6. Okay. So that means I will get 0, 11, 2 minus 0 is 2, 4 minus 6 is minus 2. Okay. So now, what is the determinant of this? Right? What is the determinant of this a minus 6i? Which is very easy to calculate. 0 minus 22. Correct? This is one part. Okay. So let's remove this. This is where I think we were. So now calculate what is determinant of a. Very simple. 24 minus 6 into 4 minus 2 into 11. So how much will that be? 2. Correct? So first is, what is the determinant? So if I were to say concept 1, determinant a, then you have factorized this, and here one more concept 2, which is determinant of ab or mn is equal to determinant of m into determinant of n. Now calculate the determinant of a to the power of 2014 into a minus 6i. That will be equal to determinant of a to the power of 2014 into determinant of a minus 6i. This turns out to be, this is where you can exchange the two operations. One is multiplying the matrix to itself and taking the determinant. So the determinant of the product is equal to the product of the determinants. Okay, something like this here, which we have written the concept 2. M into n determinant is m, determinant of m and determinant of n. So the same logic works here, and I can put the power outside into a minus 6i determinant. So now I have the determinant for both of them, right? So I have 2 to the power of 2014. This is minus 22 to be multiplied to this. So now if you look at this, there is a 2 factor here, so which can go with that. So it should be 2 to the power of 2015 into minus 11. So whichever is the option, that should be the answer. Correct? So there is an option here, minus 11, 2 to the power of 2015, which is our option 2. Right? So what are the concepts that we have used? What is the determinant? How to calculate the determinant? If you were to say how to factorize, that's also one, concept 0. Factorizing matrices. Okay, concept 2, 0, 1, 2 here, determinant of products, and then you can simplify that and get the answer. Okay, 7th problem. Okay, so this is very straightforward problem. We just need to know the definitions. Okay, so what is a nilpotent matrix? There are basically 3 types of matrices: nilpotent matrix, idempotent matrix, and involutory matrix. Okay, so what are those criteria for defining what is a nilpotent? Is that if I have any matrix A such that A square is equal to 0 matrix, then it is called a nilpotent. Idempotent is when the square of a matrix is equal to itself. And the involutory matrix is when A square is equal to identity, which means that the matrix is inverse of itself. Okay, so this is very strange. It will never happen in the case of natural numbers. So in case of natural numbers, the only number whose inverse is itself is 1. So 1 inverse of 1 is 1 by 1, which is equal to 1. But this is identity element, right, of the identity for the operation multiplication. But for the matrix, it need not be so. There is a non-trivial matrix, that means not an identity matrix, which when squared can give you identity. Like the way we have got A square as 0 matrix or A square equal to A. Remember in the first case also, in numbers, for example, if A square equal to, okay, let me not use the capital. Let us say if A square is 0, it implies that A equal to 0. There is no other option in numbers. But for matrices, you don't have to. A non-zero, a non-trivial matrix A can give you the product to be 0. So using this and verifying it, you can find whether first one is true, second one is true, or both are false, or both are true. Okay, so this is all that's needed to keep in mind and apply these concepts to solve the problem. The next one, okay, here is system of linear equations. Now this is a set of non-homogeneous equations. Okay, to have a unique solution for the non-homogeneous equation, what should I do? I should have the determinant of the matrix should be not 0. That means it should be non-singular matrix. Okay. Now, in case of this unique solution, but what are the things he has given? Either infinite or no solution, right? Now, this case will happen only when the determinant of A is equal to 0. So therefore, you substitute write down the matrix of the coefficients, which is lambda 2, 2, then 2 lambda 3, 5, and 4 lambda 6. And determinant of this when equated to 0 will give you a equation in lambda. Now for which of the lambda can this situation occur? So you will get let's say a factor of lambda is equal to 2, then you will find that it is infinitely many solutions. So that's one. No solutions is not an option. So it will usually be infinitely many solutions when lambda is equal to one of the values, 2 or 8. Infinite cases are there, right? So one of that would be lambda equal to 2 or lambda equal to 8. One way to quickly check is put those values lambda equal to 2, for example. So if we go by the verification approach, right? So I can write down the lambda equal to say 2, the smaller number, right? So I'll check for 2. 2 into 2, 4, 3, 5, and 4, 2, 6. So will this become 0? That's the question, right? Any of the 2 rows or columns are 0? No. So, but 2 is a common factor. So that means I can write 2 times 1, 1, 1, 4, 3, 5, 4, 2, 6. Then I can subtract 1, 1, 1, 3, 2, 4, 4, 2, 6 as is. Okay, this doesn't seem to go to 0. So that means lambda equal to 2 is not the case. So we have to look for lambda equal to 8. So that means that's the answer, because no solutions is not a option. So we will say, because it's not 0, there will be solution. If lambda equal to 2 and the determinant is not 0, that means there is a unique solution. So which means no solution for lambda equal to 2 is eliminated. Infinite solution, determinant is not 0, so therefore this is not option. So the only case is the infinite solution with lambda equal to 8. So this is the elimination technique that can be used. Okay, for the next problem, AI bi is some natural number, then the coefficient of x in the determinant. Okay, so this is a very interesting problem where there is a binomial expansion provided here, right? So coefficient of x in the determinant. So that is 1 plus x to the power of a1 b1 and 1 plus x to the power of a1 b2, and it goes on, right? So now if you notice, there is a certain set of the constant, or rather common factors in the expression, right? Because it's a1 b3. Oh, it's a 3 by 3 matrix. Why did I put a dot? Okay, so here in this first row you have the a1 as a common factor, so you can pull that out. You get 1 plus x to the power of a1 into the determinant. Similarly, in the second one, 1 plus x to the power of a2 is a common factor. 1 plus x to the power of a2 and a1 to the power of b1, right? Okay, sorry, there is a whole power b1 b2 b1 b2 b3, so it's a product, not the sum there. So okay, not that. So we need to figure out alternatively coefficient of x, right? So let's say you expand this whole thing in terms of the regular determinant. Okay, so that means I will have to write this in terms of the typical expansion, right? So when you do this, 1 plus x to the power of a2 b2 minus 1 plus into 1 plus x, I think this will be brute force method, and this is 1 plus x. Can you see some pattern? a3 b2 into 1 plus x a2 b3. That's your first term. So can we simplify this? The a2 b2 plus a3 b3, a3 b2 plus a2 b3. So everything is sum, and then you can a b equal to 1 2 3 coefficient of x. Okay. Okay. I need another concept here. Realize what we could do is, there is something called the derivative of a determinant. Okay, and we need to use this as a concept. So there's, I think, one more problem. So we'll park this problem, we'll come back to this problem so that we can do it easily when we realize this. Okay, has a unique solution. Again, this I think is inhomogeneous equation. Okay, So if it is having unique solution, the determinant should be not 0. So just write down the matrix and calculate what is the value, and for which value of k will it have a unique solution. So that means if k equal to 0 or k is not equal to 0 or in the limit, so that means there is an inequality for k. So you can pick any one of this and find the corresponding expression for that. Okay. So again, very straightforward problem. So you can do it, complete this part of the problem. Then, okay, so this is another which is more of row column operations. So let us see how to do this one. So you have x plus y plus z, 2x, 3x plus 2y, 4x plus 3y plus 2z, 3x, 6x plus 3y, 10x plus 6y plus 3z equal to 64, right? So now you can use the row and column operations and then get what is the corresponding simplified case. And of course, look at it, there is the value of x alone needs to be found. So that means you can start looking at the equations where y and z are there and start eliminating them. So in that way, I can choose. So that means the idea is to eliminate y and z from the elements from the determinant. Okay. So for that, I can take the second row, subtract from the first row by multiplying it by certain number, so that I can eliminate the 2y part. Okay. So if I were to do that, let's say I multiply by 2y is here. So I'll multiply by 2 and eliminate the y. So that means 2x minus 2, first row will remain the same as it is. The second row is 2x minus 2x, 0. 3x minus 2x is x. 2y minus 2y is 0, so nothing here. And here 4x minus 2x is 2x. 3y minus 2y is plus y. 2z minus 2z is 0. So that is all I get. And then similarly, I could use the elimination with the row 3 with the row 1. So R3 minus R1. So if I do that, 3x minus 3x, which is 0. 6x minus 3x is 3x. 3y minus 3y is 0. 10x minus 3 is 7x. 6 minus 3 is 3y. Okay, this is y. 3z minus 3z is 0. So that's all it is. So I have 2 zeros already. So that should be enough to try and expand it via the thing. Okay. And still, okay, maybe there is still y here in this expansion. So I need to check if I can eliminate. So one way to eliminate that is taking the multiply by 3 to the second equation and subtract from the row 3. So that means I can get this as xx plus y, x plus y plus z, 0, x, 2x plus y as it is. And I'm trying to make this multiply by 3 and see what happens, right? Because there is 3y here and y there, so multiply by 3. So 3x minus 3x is 0. 7x minus 2 into 3, 6. That is x. 3y minus 3y is 0. So I'll just get this. So I have got a lower triangular matrix as zeros, 0, 0, 0. So when you expand this, you will notice that you can choose any first row or the last, first column or the last row. And you will get that it's nothing but the product of the 3 diagonal elements, because everything else will get multiplied to 0. So x into x square into 0 times this is x cube. So you got the determinant to be equal to x cube. So that is what is 64 here. So therefore, x cube is 64, x should be equal to, so that implies x is equal to 4, right? So that's the option 2. Okay, so option 2 is the one which gives you the correct answer. Okay, so look at the way what we have done in this problem. We are looking at cases of how to eliminate a variable, and in the process we also saw that we are getting a lower triangular matrix to become 0. So it's easier for expansion for the calculation of determinant. So that's the trick and the idea of how to calculate or simplify the calculation of determinant. Then, so this is another problem wherein we have adjoint of a matrix. So here there is another concept which is very important for us, which is what is the, and also remember this is the determinant here. So there is a property of these determinants and we know what is an adjoint of a matrix. Right? So adjoint of a matrix is defined as the transpose of the cofactor matrix. Okay, transpose of the cofactor matrix. So which means that I can write down the cofactor matrix for this and then write the corresponding transpose to get the adjoint. Now, how, whether should I write all of this or what is the relation? So that is where we have to look into. So what is the determinant of the adjoint of A? That's what we need to know. What is definition of adjoint of A? That's one part. But what is the determinant of adjoint of A? It turns out that the determinant of the adjoint of A is, there is a theorem that tells you this, it is determinant of A to the power of n minus 1 for an n by n matrix. Okay, so that's the theorem. Okay, so now in our case, we have a matrix A which is of 3 by 3. So therefore, the determinant of the adjoint of A here is what? To the power of 3 minus 1, which is 2, right? Now look at this, adjoint of A. So let's say adjoint of A is some matrix B, right? So let adjoint of A be equal to B. Then he says, what is the adjoint of B? Remember, adjoint of A is also a 3 by 3 matrix. So what is the determinant of adjoint of B? It is the determinant of B, like the way in the previous case, B square. So what is the B? It's nothing but determinant of adjoint of A. And this square is already there. So what is determinant of adjoint of A? We got it as A square. So therefore, I get this as A square whole square, which is mod A to the power of 4. Okay. So I have expressed the required expression here, the determinant of adjoint of A in terms of the determinant of A. So if I calculate what is determinant of A, a number, then I can simply raise it to the power 4 and I will get the answer. So that's a simple idea which we can use and verify what is the correct answer. So next step will be calculate determinant of A and raise it to the power 4, so that should give you the answer. So what is the concept required to find the answer? We have already discussed. So what is the definition, which theorem, and therefore what is the final answer? So you can come up with the verification as which is it 64 or 256. 6 cannot be, 8 cannot be, because 2 cube is 8. So it should be between 64 and 256. So if you look at 2 power 4, it is 16, and 4 power 4, because these are numbers, right? So if you can guess, if you want to do a guesswork, you will see that 2 power 4 is 16, that is not there. 1 power 4, 1 is not there. 3 power 4 is not there. So the only option that can fit in probably is option 2.
Sir, option B, 256.
Yeah, so it will come as 256. So without calculating the determinant, I'm trying to guess. Okay, so that is like fitting 2 power 4, 3 power 4, 4 power 4. And it turns out that 4 to the power of 4 is the available option. So as one of you have verified, option 2 is the answer. Okay, okay, I think, yeah, Tejas has got the answer also, 256. Right, so that's one quick way to apply. And right, next problem. I think we're going a little slow. Let's see if there is something which, okay, let's pick up this problem and then see if there is a repetitive kind, we will skip, and at least a few more problems can be done. So consider a variable matrix. So some x, y, z, y, z, x. Observe quickly that this is a symmetric matrix. So V is a symmetric matrix. V is symmetric matrix. Okay, then such that VA equal to 0. So some A, which is given as log A, log B, log C, that goes to 0. Right, that's the equation. E is the equation. Okay. And ABC are distinct positive real numbers in geometric progression. Okay. So if ABC are in GP, we had a problem earlier which we discussed, that if ABC are in GP, the corresponding logs of these elements numbers will be in AP. So that is to be kept in mind. So now if solutions XYZ of this equation lie on this x by alpha, y by beta, z by gamma, then the value of, so if I can get what is the values of x or y, z or alpha, beta, gamma, in what proportion they are, then we have the answer. So x is to y is to z is what something we need to find out, because it's given in terms of the ratio. So therefore, let's write down the equation. So you have x. Okay, let me multiply and directly and write down, save time not writing that. So if I multiply x into v into a, that will give me x into log a plus y log b plus z log c equal to 0. Okay. Similarly, I get y times log a plus y, sorry, this is second element is z here. So z log b plus x log c is equal to 0. Similarly, z log a plus x log b plus y log c is equal to 0. Okay, so this is the kind of matrix symmetry that it has. So let us see if I can try and eliminate some set of equations, right? Okay. Okay. ABC are in GP. So that's also something that we need to keep in mind. What can we do to simplify this? So we need X is to Y is to Z. So that means, can I subtract these two equations? I will get X minus Y log A, log B, log C. And similarly, this set of equations. We cannot eliminate, right, any one of them in this manner because it's cyclic symmetry. What if we use one of them as X by alpha, Y by beta, Z by gamma? Okay, yeah, we know something here. ABC are in GP, which means that I know A square equal to, B square is equal to, right? That's our property. B by A equal to C by B. So B square is equal to AC. If I were to take the log of this, I get 2 log B equal to log A plus log C. Okay. So that means I can replace log A plus log C as 2 log B, or log B in terms of log A and log C. This is where can we add two equations and get 2 log B? Which two equations can be? Or let us say we just substitute for this. Add these two equations. I get X plus Y into log A, Y plus Z log B, X plus Z log C. Okay. Now I know the trick is it is log A, log B, log C are variables. X, Y, Z are your coefficients. If I were to look at it from that point of view, I can no, I am at a loss for this. So let me park this. I will get back to you on this problem. So there is a trick that we can do in order to get this ratio X is to Y is to Z, which is like basically the ratios there. We have the information given. How to use it is to be checked, right? What is the best way to do it? Yeah, I think I have an answer. Trick. A, B, C are in GP. B square positive reals, A, B, C not. Okay.
Sir,
Yeah.
if we take XYZ by any three GP, we can get.
If X, Y, Z are
Replaced by GP numbers. Like 1, 2, 4.
no, that's not given because we don't have that information. We cannot use that criteria. Okay. So what we have, the information is all that we can use. At most I have B square equal to AC log A plus log C is there. X plus Z. Then there is pi plus Z. I've made some another assumption. Which is actually not. Okay, something is missing in this problem, I think. Okay, so 13 has a challenge. I'll come back to you. I think there is missing condition probably. Okay, this one, next problem, just before we wind up. I think this is again the same way you can do it, which is an inhomogeneous equation. And of course, here you can go through the matrix method wherein for the unique solution to exist, the determinant should be not zero. So instead of trying to find the inverse and multiplying and all that, you can just quickly substitute and check. So take any one of the equations and try to substitute. So one of the tricks which you can see is, if you put all positive numbers in the first equation, you will see that it will not be equal to 1 because everything is greater than 1. So therefore, first option is not correct. And then if it is negative, -3. So let's see if probably Z is -3, will it work? So 2 into 1, 2, plus 2, 4. 4 minus 3 is 1. Oh, it worked. So second option works. So now try for the second equation. So will it work for that? So 1 minus 4 minus into minus plus 9. So that is not going to be 1. So that means option 2 is wrong. So let's go for the option 3 with the first equation, going back to the first equation. So 2 into 1, 2, minus 3, 2 minus 3 is -1, plus 2 is +1. So 3 is an option. And also remember, already in the first case, you argued that all positive numbers cannot be true because 2x plus y plus z cannot be equal to 1 if x, y, z are all positive and natural numbers, right? So therefore 1 and 4 can be eliminated. It is between 2 and 3, and we eliminated 2 in the second equation. So therefore the third one seems to be agreeing again. So therefore that's the only option left. So therefore option is 3. So if you notice, the approach I took for this one is purely logical and argumentative approach of elimination technique and seeing how to say which one is not true. Okay, and the basic math that helps us eliminate the options. So the way option 1 and 4 are not, the solutions because all are positive numbers and it cannot be adding up to 1. So those are the logical arguments that we can use. Okay, so many such problems are there. In fact, I had very ambitiously put in some 40 problems as we were discussing, and I think we could only cover about 15 problems, 14 problems, with 2 on my side to be discussed yet. So let's take it up in the next session and maybe offline because I think we have very few such sessions to handle. So let's see how to arrive at these different tricks. Let me make a list of tricks and maybe approach this solutions of the problem. What are all the different tricks that are applicable to these types of problems in these JEE type of problems? Okay. So with that, let me end the session here. It's 8:30, so I'm sure you'll have other work to do. So let's catch up with you guys again. And so all the best. I'll share this set of problems so you can take it as assignment and submit it to Raghavan sir, or in the group. You can't post it, so you can post it to me directly, or let's find out a way to solve it. That issue of how to take it as assignment and returning it to us. Okay. So all the best. Good luck. Bye.
Thank you, sir.
Thank
you,
you.
sir.
Thank you. Bye bye.